So I'm Mike, and I'm co-founder and CTO at CodeStack.io. I'm also one of the core contributors to React Native. If you are using React Native, you probably know me from announcing React Native releases and publishing changelogs. And today I'm here to talk about bundlers, how they work, and how they relate to React Native. I feel like it's kind of a bit of hard topic as a first talk, but I'm really hoping you guys will kind of enjoy it. So let's start with the most fundamental question. What a bundler really is. How many of you have an idea what a bundler is? Please raise your hand. All right, so it's like 50-50 more or less. So this might be the most educational presentation I've ever made so far. So I really feel like, I hope that you guys will enjoy those graphs. I kind of put a lot of effort to make them look nice, but I really kind of feel bad about them anyway. But yeah, it's like bundler is a tool that simply takes all your JS source files and puts them into one file, right? And that process is called bundling. There are many of them these days, with Webpack or Browserify being most popular. So you are probably now wondering, why do we even need that, right? Like, why do we even need to merge all the files into one? So to better understand that, let's step back to early days of web and see how the things used to be. So historically, JavaScript hasn't had any standard for requiring dependencies from your code. There was no import or require statements available. So how did we make functions of our code visible to the outer world? Or how did we import third-party code to our application? The only way was through global variables, right? So for example, if you wanted to use jQuery, which was pretty common those days, you would go ahead and add a script tag that loads it from external resource. As a result, your global scope would get populated with its bindings. In this case, a $sign. So one could say that this is actually neat, right? All said with just a few lines of code. However, imagine this scenario. Your prototype works out, your application grows, and you end up looking into splitting your file into smaller, reusable pieces. So you would end up with something like this. Now the code will get executed, and the script tag should have access to all the global variables as defined in the preceding files. The problem here is the order. What if Food.js wanted to depend on bar.js code? You would have to change the order, right? And manipulating that on scale can lead you to weird issues. And it's more like it's kind of similar to callback hell, and I often call it a script hell. So how do we solve this? Turns out it's been already solved in other environments, like for example in Node.js, that implements its own module system using require functions and export object, amongst other things on top of the common JS module spec. So what if we could do the same in our front-end code? That would be great, right? However, there is one technical limitation here. The require itself is synchronous. In Node.js environment, it's fine, right? Because when you want to load a file, it's kind of physically available next to the file you're already in. So that's easy. However, in context of web, you need to make an HTTP request to load a file that has never been processed by the browser yet. And that request is async. So the solution is simple. You can bundle all the files into one so that we have them in memory at the time of the require function being called. And that's the primary reason for the bundling explained in under 5 minutes. So bundlers can be perceived as a natural evolution of task runners that we know, like Gulp and Grunt, that happened over the course of a few years. There are lots of responsibilities in scope for them rather than just getting your code bundled into one chunk for the sake of organizing dependencies. One of them, for example, is transpilation. A typical bundler can or has support for transpiling your code. That means for reading input source in particular format, for example in newest JS spec, and outputting it in an older supported format like ES5. The most popular out there is Babel, and most bundlers out here provide a first-class integration with it. So we mentioned already that in order for require to work, your entire application has to be loaded into memory. That causes your bundle size to increase and ship with modules that don't necessarily need to be loaded on the initial page run, right? So code splitting is a feature that allows you to split your code into various bundles, which can then be loaded on demand or in parallel. And in ES 2015 compatible environment, for example, you could use import function to obtain an instance of a module. The premise is resolved as soon as the loading process is finished and an instance of a module is available. And the last feature that is worth mentioning is the code minification. For example, Webpack 2 has support for tree shaking. That means it can determine what parts of your modules are not used. For example, you don't use one function of the full module, and effectively remove those parts from the bundle. Combined with other minifiers like Uglify, it can contribute to smaller bundle sizes that get delivered to users. So that's a bit of theory. Now, how does that all relate to React Native? Because we are at the React Native conference, so the talk should be purely about React Native stuff. So with React Native, we express our native mobile apps by writing JavaScript, and layouts by writing React components. However, both iOS and Android have no way to run JavaScript, right? They are distinctive platforms with their own languages, SDKs, and tools. So there is no easy way to do it by default. However, those all platforms have one thing in common, which is the ability to spin a JS VM that can process and execute your code. And React Native does that and then sets up a bidirectional data flow that is called a bridge, which is a layer that can accept an arbitrary JavaScript call and can forward it to the native module and get back some results. So the use of JS VM is what makes the constraints we just talked in context of web applicable here as well. So just to give you a great example. For example, on iOS, React Native uses JavaScript core to execute your application bundle. Its features and performance change on per system basis. That means you'll get a different JavaScript spec supported on your Mac than on iOS 8, 9, and 10 devices. So that means like more or less 4 environments that your code can be running in. So we definitely want to transpile that to the lowest subset supported on all those devices. So sounds like React Native is pretty similar to web, right? We have access to some of the same polyfills, globals, APIs. The language and spec are also the same. We bundle code the same way. There are even modules on NPM that work in both environments. However, there is only one thing that's fundamentally different. And it's the React Native start command that we run every day. At first glance, all it does is it serves your application bundle at the given URL that can be accessed on your local host. Pretty simple, right? So why don't we use, for example, Webpack and configure it to do exactly the same? I like experiments, so I felt like why not doing it? So I like Webpack for the fact that it has a nice declarative interface, which is its Webpack config. So what I did in first place is I created an empty config where I could just point to an entry file and define some other settings for React Native to load the bundle. Then I thought of all React Native specific features that I knew about, and I tried to support them in order for my prototype to work. So one of them was, of course, the dev server. React Native works by loading your bundle from the URL. In most cases, it's the name of your entry point plus that platform.bundle extension. And it works by default on port 8081, so you definitely want to do it the same way. Then I had to integrate Babel, of course, to transpile ES6 and whatever I had to run on my iOS device. And by default, React Native does that to your entire Node modules, including even those that don't need it, which causes some weird issues like recently with the 0.46 release. So to make my experiment backwards compatible, I decided to conditionally whitelist all modules that start with React name. So for example, React Native or any React Native plugin would get transpiled. On slide, there is also Expo, because I was using some of their navigation solutions. And last but not least, to make my platform-specific code to run, I used resolve.extensions to define the order files should be resolved when I'm calling require. So in this case, I wanted my implementation to load first platform-specific file, then native file, and then end up with loading just a JS file. And finally, the most entertaining part was supporting Facebook proprietary node haste system. Now, if you don't know it, it works by annotating any file you want with provides module, and then that file can be globally required across the entire project by its name. That way you can have them spread across the entire repo without thinking where they are. So that's what Facebook is or used to be using internally, and that's the reason why it kind of leaked to React Native and is present there. So of course Webpack has no idea how to support this. And what it will try to do is it will try to get those modules from Node modules. But since we don't have them, we'll end up with an error. So we definitely want to somehow overcome this. But Webpack has a great feature, which is the resolve.alias. It is a map where keys are name of the modules that can be globally required, and values are absolute paths where those files are located. So my solution turned to be quite dumb but perfect in terms of performance. I just decided to glob for all JS files across the folder, check the doc block, and if it was provides module inside, I was just assuming it's a no-haste file. So after hacking with it for a few nights, I finally got it running. In less than 7 seconds, Webpack created and served a bundle on port and URL that I wanted. I thought, great, it's nothing but declarative Webpack config and I rule the world. But my excitement went away as soon as I realized that opening a mobile app actually results in a red screen. I've noticed lots of errors, images were not showing up, live reload wasn't working at all. Debugging Chrome started producing red screens, and by that time I didn't really know what runtime is not ready meant. More importantly, red screen messages started looking weird. The struct trace was unreadable. It's even unreadable here anyway, but it was kind of impossible to locate original file because it was saying index.bundle and some minified lines, so kind of crazy to debug. So I started to realize that in context of React Native, there has to be more than just a bundler that is running. Turns out, running React Native start spins up an entire set of tools that are focused on providing you with a better developer experience. At its core, there is of course that bundler. All the rest are just complementary features built on top of it. And I call it a packager. I know it might be confusing with React Native packager, but since it recently changed the name to Metro, I decided to steal it for the sake of this slide. So packager is a tool that is used to develop, debug, and package an entire application. It builds on top of an arbitrary bundler like Webpack and ships with pre-configured set of transforms and settings required for your code to run in this environment. So I decided to keep my experiment going and see if I can make Webpack work with React Native. The plan was to support all its features, including some links that never worked with React Native before. Now there were many React Native and Webpack integrations before that, with React Native Webpack server being one of them, if I remember. But the problem with those was that there was still packager running in the background. The way they were set up was that Webpack was processing your code first and then giving it to packager to process the final bundle. What we wanted to do here is we wanted to get completely without packager or anything related to packager and just use Webpack and whatever there was on NPM as well. So in particular, I was interested in the boundary. Where is the boundary between React Native, the bundler, and the rest of the tools? And I was wondering how many things I will have to write on top of Webpack in order to make it fully working with React Native. So the first thing I started looking into was the Chrome debugger. On standard React Native app, turning that mode opens a new tab in your browser. However, there are no APIs on iOS or on Android for opening a Chrome tab on other computer, right? So I quickly realized that it has to be a packager that is opening that Chrome, not React Native device. And since the packager is a process running on a host machine, it has access to all the native APIs that are required for this action to be done. So the only thing that was left was to figure out how do those two pieces talk to each other. And turns out packager is an HTTP server. It is composed out of standalone middlewares, each having a different responsibility. Together, they form a tool that provides the developer experience we know from React Native. It's a really cool and powerful concept. Being able to plug and play certain parts as middlewares makes it very customizable and hackable. As you can see, this is actually the code that I just copied from latest React Native like a few days ago. The last middleware here is the packager server, which is the Metro bundler React Native uses. And the rest are just the things added on top, like status page middleware or OpenStack frame in editor middleware and other things like that. And the communication is established by React Native, calling packager endpoint. Then the handler is executing procedure on the host machine and reports back to React Native client with the status. As you can see, it's very similar to remote procedural call that we know from distributed computing, with a small difference that everything happens on your local host. So in order to get my project rolling, instead of spawning Webpack from command line and relying purely on its config, I decided to use Express Server and Webpack Dev middleware for that. That way, I could still get an instance of an HTTP server and combine that with the powerful config that Webpack had. So after I got it working, that way I started to rewrite and add in the missing middlewares. So let's just go over for some of them that I had to re-implement, create, or just copy. One of them is the live reload middleware. And as the name indicates, this is the middleware that's responsible for live reloading your app. Right? You have this feature in your mobile devices. On your mobile devices, you open DevTools and you see turn on live reloading. Once you turn it on, every time you change a file, your app automatically reloads. So the way it works is, once it's activated, React Native sends a long-lasting GET request to the packager. On such request, the middleware stores a response object associated with particular request. As soon as changes happen to files in your file system, for example, in this case, I can attach done event on compiler. Compiler is an instance of Webpack. All connections are going to be closed with change true payload. That indicates that the client, in this case React Native device, should reload itself. Now that we have a better understanding of how the communication between packager and React Native is done, we can look into solving those two red screens that we had previously. One of them was the runtime not ready, and the second was the bad error messages. So I'm quite excited about that one because the ability to use an arbitrary browser to run and debug the business logic of my mobile app was like pure magic when I first heard about it. So what happens is, as soon as you turn on Chrome debugger from the DevTools, React Native executes that remote procedure to launch DevTools inside Chrome tab if necessary. Right after, both device and the debugger connect with each other by using WebSocket connection. Since there is no way for them to connect directly because we are dealing with a Chrome tab with its own limitations and device, they have to use packager, which acts as a WebSocket proxy between them. And if for some reason the connection cannot be established, you end up with runtime not ready exception that you can often see. So once all's well and good, WebSocket executor on the device sends the JSON message to the Chrome tab. It is a JSON object and it has to contain at least a method property. It tells the debugger which handler to execute. The rest of the keys varies on a handler basis. In this case, this is the first payload that's ever called for the WebSocket connection, and it's to execute application script. It's so called a special handler because it's hard-coded in the debugger. What it does is it takes everything that's inside inject, it parses it, and then it puts it on a global object so that you can access that globally later. And the next thing it does is it uses web worker import scripts to synchronously load JavaScript at given URL into the scope of the web worker. And then the execution proceeds normally. But if given method is not a special case handler, its handler will be looked up at the FB batch breached and executed. So the communication pattern that you just seen is pretty much the same when you are using JavaScript core on iOS device. The difference is that instead of using WebSocket executor, you are using JS core executor. Historically, there also used to be a WebView executor that was used for debug with Safari. Once I got the debugger up and running, I started looking into those weird error messages. Now, I didn't include that in my initial prototype when I was working on that integration. Steve Kellogg from Infinite Red contributed it later. Thank you for that. However, I find it very interesting, so I decided to describe it also in this slides. So what happens is that as soon as there is an error, React Native asks Packager to symplegate your stack trace. If you ever had a red screen, you probably noticed that after a millisecond, the stack trace changes, like something changes there, like there is like a change. And that's because of that async request that happens in the background. So what happens is, as soon as we get that request with the payload that we'll explore later, the first thing we do is we create an instance of source map consumer. We pass it a raw source map, as for example read from the file system. In this case, I removed it for the sake of making it smaller. However, the code for that can be found on GitHub, and source map raw string was just taken out from the Webpack memory file system. So source map consumer represents a parsed source map object that we can use for looking up the original details about the file, location, and other things that we want to do. We then map the request body, which is an array of all the frames for the error that we got on the device, to the original source, line, and column information that we get by querying source map consumer. And such array is then sent back to React Native and replaced on the red screen, and that's why you see the difference. So the reason I'm telling you this is I believe that bundler implementation should be pluggable. The packager in React Native does way more things than just compiling your code. And those things are not trivial, right? Some of them were carefully designed over the course of months. And from my experience, it took me like 2 weeks to implement Webpack to work with React Native, and I still got a lot of bugs to deal with. If the entire platform was pluggable, it would have been way easier. But do we really need that? Like, what's wrong with just React Native packager being there in the wild? Let me answer this question by asking you another one. Do you want symlinks? Lack of support of them was for long one of the most common issues with React Native development, especially for library authors. React Native promised us the workflow we know from Web and Node.js and brought it to the world of mobile development. However, breaking that expectation was painful for many people. Now, it is because the default Metro bundler uses Watchman to listen for file changes and reacts accordingly. Now, Watchman is a Facebook open source library constrained to provide maximum performance when it comes down to listening for changes on your file system. One of its limitations, for the sake of speed, is that it doesn't listen for changes in symlink locations. And it's not clear whether this feature will get implemented, if ever. And it's perfectly fine, because at Facebook scale, lots of milliseconds that seem irrelevant to us matter a lot. And now I'm really happy and glad that we get a lot of performance improvements for free. Like recently, they contributed a lot of improvements to source map generations. However, at the same time, I believe it should be we should be able to opt in for a slightly slower solution, but more feature rich and kind of designed to solve our use cases. That's why at ColdStack we made Whole. Whole is a drop-in replacement for existing packager. It builds on top of open tools like Webpack. At its core, we have the Express server with those pluggable middlewares. It is a hackable dev server with predictable workflow. Most of the code snippets that you have seen today can be found on the repo. So if you got any questions regarding to the things that I missed on slides, please check it. And here's how it feels. You first select the platform that you want to prepare bundle for. And normally you do it by passing a flag. But I guess many of you have often mixed flags or forgot about them. I do it all the time. I never remember how to run on a remote device. I always have to check help and see what's the name of the option. So we thought instead of exiting with an error, we're gonna ask you to provide it. And more importantly, we're gonna show you how to run it next time, so you don't have to answer it over and over. After the process finishes, you just wait for it to bundle and you're ready to go. And we designed it carefully around best developer experience, taking as much inspiration as possible from community leaders such as people that contributed to create React app. In fact, if you've been using it, you can probably tell that it's very similar and looks almost the same. And there are a couple of reasons why we made Whole. Two of them we already mentioned today. One of them was support for symlinks, something that we wanted to die for, especially in our monorepo kind of setup. And the second was to embrace potential of pluggability and make something that can be extended in an easy way. And the last one was that Webpack is just awesome. Now, I was thinking about this slide for a while because I'm not gonna lie, when I was writing Whole, I ended up like almost killing myself trying to understand how to write plugins for Webpack because of docs. The rest is great, I like the docs very much. However, it's like if you really want to understand Webpack, you have to write a plugin. Then you will go over all the repos, check all the source code, and then you will understand it. But it's still awesome, and people who made it are also awesome because they came up with those abstractions. And what I like about it is that it's extensive, well-documented interface. And it has a very broad ecosystem. It opens a lot of exciting possibilities for us. We can even, like, I don't know, think of some crazy things like writing CSS to style your React apps, React Native apps, for example, if you are not a fan of inline styles. Or, I don't know, like using TypeScript or some other weird loaders. One of the common issues in the past was that people wanted to use JSX, and that extension wasn't supported by React Native Packager. With Webpack config, it's like one line of code. And also, if you are already using Webpack on the web, it gives you perfect opportunity to share your code. Things like aliasing or, I don't know, like changing extensions or per platform basis, those are just nice helpers that can help you to write a cross-platform universal app. And there are lots of features missing that we are working on. Currently, our top priority is to increase its adoption so that we get more bug reports and we can make it faster and better. If the idea of Whole sounds interesting to you or you wanted to use it, please do it and let me know what's your opinion, what are your ideas, whether it works for you or not, and we'll do our best to make it work for you. And as I mentioned, I'm really looking into making Whole a platform for other bundlers to run. There are faster or maybe different alternatives to Webpack that can work for you, like Fusebox or Metro Bundler. And I believe that one should be able to use whatever works for him to bundle the app and still get the first-class user experience and developer experience that Whole gives him. Thank you.